Now we're going to do an investigation of what happens to the air molecules when heat is added, when that energy is added. So I have a bottle here, nothing on top, so it's an open system. There's air inside, air outside, moving freely. So I need to make this a closed system. I'm going to do that by putting a soap layer on it. Okay? So now the air that's inside is trapped inside. Air can't get in, air can't get out. So I'm going to put it in hot water, and let's see what happens. All right? Now I'm going to put it in cold water, and let's watch what happens. We keep watching, because I left it in the hot water too often. But watch that bubble. So it's getting pushed down. So what's happening here, it's a closed system, all right? So when it's put in the hot water, the energy, the heat energy from the water transfers to the air molecules within the bottle. They start moving around faster. So that means they're hitting the soap more often, which causes the bubble to form. Because the air molecules are moving so fast, so it increases the chances of hitting the soap and it forms up. Then when it's put in the cold water, well, they're slowing down, they're losing energy, right? So they're losing energy, they're not moving as fast, they're not hitting the soap as often, which allows the air molecules on the outside to hit it more often, which pushes it down. Because air cannot pull, it can only push. So we've shown that the hot water heated the air molecules within here, which yesterday we looked at the temperature on the ground versus up high. And I stated that the ground is transferring heat energy to the air molecules. This shows that yes, it does happen. You saw it. When I put this bottle into the hot water, the air molecules gained energy, they moved faster, they hit the soap more often, which formed the bubble. That's evidence that yes, air molecules move faster when they gain heat energy. We put in the cold water, they lost energy. Evidence for that? Well, the bubble became concave because the air molecules within the bottle were moving slower, so they did not hit the soap as often because they're not moving as fast. But the outside molecules are still doing their thing, and they're hitting it more often than the ones inside, which pushes the soap down. Okay? Now, on your papers, you answer questions 1 through 4, and then you're going to draw a model of what's happening in the cold water, what's happening in the hot water, inside the bottle. Look at the very first bottle. You got to count the number of molecules. This is a closed system. Once I put the soap on, it was a closed system. So air molecules did not get in, air molecules did not get out. So you have to have the same amount of molecules in each of your bottles because it's a closed system. Then you have a CER. Use the evidence of what you saw. What did you see when this bottle was placed in the hot water? What did you see happen? What did you see happen when this bottle was placed in the cold water? All right, and then provide your reasoning. Reasoning is always at least 2 sentences. Why did this happen? What was going on? Think about energy and what energy does to molecules. All right then, that's it for this one.